Alright, so we've got the power board that I was working on yesterday. I finally found a data sheet for this chip, and through the pinout I've found that this pin here is the power good, so there should be voltage on that up to 0.5 volts when the chip is enabled. Let me just pull up my data sheet here. So this should be up to 0.5 volts, this first pin here. These two are no connection, but they're connected through this. This is power in, and there's actually 3 pins right here underneath that are actually power in as well. These are all ground. These two, this one, and there's these two here are all connected together to this. This is the power output. And then we've got, this is VCC, this line here. Enable is this line here. And what I found is that if I trace enable through here, it actually runs, how did I find, oh no, when enable runs, what did I find here? Don't remember how this worked. Enable, the enable chip runs, I think, to here if I remember right. Then from here it runs all the way over to this capacitor, this resistor. Other side of this resistor it runs over to this pin here. And this pin here needs to have 3.3 volts on it in order to enable this chip to turn on, which is what I thought originally, that this chip is actually directly controlled from the main board. And so what I found is that there is the enable signal coming from the main board on this. It's getting to the chip, it's arriving at the chip is trying to turn on, but it can't, because according to the data sheet on this chip, the supply voltage in, which would be these 3 pins here and 3 pins here, which come off of this whole area here, needs to be at least 14 volts, anywhere between 14 and 28 volts, and the charger is 19.5 or 24, depending on which board you're using. And I didn't notice before, but right here we've got a fuse, and this fuse, we'll check it together here, this fuse has 0 continuity on it. And that is why all of these capacitors and this whole part of the board was only at 2 volts yesterday. And so all I should have to do is replace this fuse, because I've checked already. If, let me just show you here. If I plug in 19.5 volts into the board, so we'll hook up our alligator clips here, turn on our power supply. Okay, power supply is on. We're at 19.5. Not drawing any amperage, which that's fine. We don't have anything hooked up to it. So if I show you this side of the fuse, oh, DC volts, there we go. This side of the fuse, we've got our 19.5 volts input, which should then be going through the fuse into this part of the board and feeding our power IC here with 19.5 volts. But what we have is only 2.3 volts, which I'm surprised there's actually any voltage there at all, because if this has 0 continuity at all, you would think that we'd have 0 volts here. So, but yeah, I should just be able to change that out, and hopefully that chip, when it gets the enable signal from the main board, it will work. So that's what we're going to do. We're going to change out that with a little bit of wire just for testing. So I'm going to take just a little bit of wire here. Some very fine wire, and we're gonna replace that with this, and we'll see if it works. A little bit of flex. One side of it, and I think I'm just going to solder the other side to one of these capacitors. Probably use my small tweezers for this, but this will work. Oh, that fell off again. There we go. Ah, of course. You know you want to stay on there. Oh, that's not ideal, but come in. Yeah, this stuff is thicker than I thought it was. Doesn't want to break. There we go. Okay. Now let's check for continuity. So now we should have continuity between here and here. Yep, and we do. Okay. Just check that again. Yep, that should be fine. Okay. So now, if we inject voltage here, hook up our ground. Now if we inject voltage, we should have... Well, we don't have an explosion, so that's good. No popping sounds. So we've got DC volts. Got our 19.5 there, and we've got 19.5 there. Okay, so my jumper wire did work. All right. I don't really have a good way to show you guys the TV because it's actually behind me on the floor. Well, actually, that might work. I've got a little portable webcam here I can set up. See if this works. That might work. Alright, so we'll take our board, our newly jumpered board, let me give you some more light here. There we go. Alright, let's put our board back on here. Not sure what I did with the screws. Thought I had them here, but I guess I don't. Would really like to hook that up with some screws just so that we're grounded. Ah, here they are. Hopefully you can hear me alright, the microphone's a little far away. Alright, that should be fine for testing. Got our power adapter here. And okay, moment of truth. If we plug this in and we hear a pop, or we plug it in and maybe the LED will actually turn on. Let's find out. Well, no pop. Press the power button. Got nothing. I'm still hearing that power regulator on this board here buzzing. So that's the regulator that's sending the enable pin over to this board. Let's see what we have for voltage here. I think you guys can see that. Should be ground. Let's double check that. Should be, that's ground, okay. Do we have anything on this yet? We've got nothing there. Should have 19.5 there, we do. Our enable pin should be here. Should be getting 3.5 or 3.3 there. It seems to be going high for only a second now. It was working before. It was giving me 3.3 how it should. Oh, there it was. I saw it there for a second. There it is. Yep. 3.6 it was at. Okay, so we are getting the enable signal. We're still not getting any output out of that chip. So we fixed our fuse. Got our 19.5 volts there. 19.35. Wait, what's going on there? It's jumping all around when the enable signal hits. It's dropping down to 17. I wonder if that wire is thick enough. You might be trying to pull too much amperage through that wire. Dropping down to 18.5. Yeah, it's totally constant on that, but on these capacitors it's dropping down. Well, it might be that the chip is drawing too and that it's dropping down from that. It's dropping down to 17. is dropping down. We still have nothing on the screen. Okay, well, we did fix one issue, and that was that we didn't have any voltage there because that fuse was popped. But now we're running into a different issue. Again, you know, I don't know whether this main board is good. That could be what caused both of these boards to blow that fuse. So, I mean, it might not turn on even with that fuse fine. I have no way to actually test this board. So, yeah, at this point, I'm thinking that this board here is fixed, our power board is fixed, and our issue now lies on the main board. So I guess the next step is to get a known working main board. Could possibly take the one out of the 65-inch that I'm working on. The one that has the weird purple and black stripes through it, and it's got like static in amongst the purple and black stripes. But now that I know that that fuse was blown on both of these boards, I can jumper it on the other board for the 65-inch, and hopefully that will bring back my power on the 65-inch, so then I can continue doing testing on the 65-inch. I think I'm done testing the 55-inch. I don't think there's anything more that I can do with this. It's probably good for parts other than this, and probably the power board, because again, I don't know for sure whether that's fixed, but I'm pretty sure that the power board is back in working order. It's just that the main board is not turning on. So at this point, I think I'm done working on this for today. I will get back to you when I get the main board for the 65-inch here, and I can hopefully test that tomorrow. Oh, maybe not tomorrow, maybe Wednesday, probably. I will be able to test that. And then we can see what's happening with that board.